Hello and welcome to another webinar of the FKA Academy. My name is Adrian Slocky. I will act today as the moderator and the speaker in the same person. Today we're going to talk about the introduction of automated driving and some more topics in this area. But before we start with the topic, I would like to give you some background on FKA Academy. This is a free online webinar of the FK Academy called 30 to the power of 3. The idea is that we're going to have now 30 minutes of interesting presentation on a specific topic, and then we're going to have 30 minutes of discussions, and this presentation will be online available for 30 days. So you can rewind for 30 days and watch it again. And it's going to be 3 topics in total. I will kick this series off on automated driving today with an introduction. Next time we will have a very interesting session on the function development and all the components that are necessary. And the third one will be on validation and on safety assurance, where we're going to present measures, methodology on validation and safety assurance of automated driving. As I said, my name is Adrian Slocky. I'm here with FKA since 10 years, leading the department for automated driving. I have one slide to present to you what I'm doing in my everyday job. So in automated driving, we are developing functions on different automation levels, mainly ADAS, but also level 3 and level 4 functions. We are doing, of course, a lot of simulation where we create simulation models of components on functions. This can be all kinds of simulations, model in a loop, software in a loop, hardware in a loop. And of course, as this third presentation will be in a couple of weeks, we are dealing with testing, validation, and safety assurance methodology. It's all about data, how to collect data, how to use data in the right way, and how to achieve the results necessary to validate and ensure safety of these functions. And that was a very brief introduction, and I'd like to give you the overview of today. So for the next couple of minutes, this is what I will talk about, the introduction of automated driving. I will talk about motivation, so what kind of automation do we have? What are we talking about when we use the word automated driving? I will give you a brief overview of some milestones in terms of history. Then the main part will be on automated driving, on how are these functions, what is automated driving on different levels. I will discuss this not purely on technical level, since automated driving is a very large topic. I will give you the current state of the art in those topics, where we are. I will point out some research questions, and in the end, I will give you an overview of ongoing research activities. So there are many ongoing research activities. I will give you kind of an overview so that you have a feeling what's going on at the moment. So that is the agenda for today. Let's start since the time is limited. And I will start with a video that I have taken in the year 2007 or 2008. So if you look in the mirror, this is me on the motorway driving a self-developed autopilot. So that was before Tesla. You cannot see it, but I do not have my feet on the pedal, but you can see that I don't have my hands on the steering wheel. And we were driving a level 2 function. I was still monitoring the environment, the traffic, as you can clearly see, but I didn't need to accelerate, decelerate, or steer the vehicle. So that is one form of automated driving. Another form is here of my colleague Sebastian, who will give you the presentation next week. It's a valet parking system. So this is completely controlled by the function itself. The vehicle is driverless, in fact, so there's nobody in the vehicle. And the vehicle is able to find a parking space in the parking lot and park itself. The third thing as a video is the so-called robo-taxi. So these are higher automation levels. We still operate it, of course, with a test driver. This is our test vehicle, the FKA vehicle, where here my colleague Benjamin is starting this drive, and you can see he just put the vehicle into gear, and the vehicle starts itself, it's steering itself. He's a safety driver, of course, since we are still in the development phase, but basically the idea is that the vehicle can drive itself from A to B without any intervention of the driver, and maybe at some point even without the driver monitoring. But I will explain more in the next couple of slides. So these are different forms of automated driving. As you can see, these are all ways of automated driving related to a vehicle. There are also other vehicles, not passenger vehicles, but maybe shuttles, so different forms of vehicles. I will give you some overview as well. Let's start with the history. So automated driving is actually something which is going on since many years. There's a lot of media attention to automated driving coming up in the last couple of years, but we actually started in the end of the 80s, at the beginning of the 90s. So there was a European, large-scale project called Prometheus, in which the basic ideas was actually formulated and tried out the first time. So what you can see here on the top left corner is a vehicle which was actually driven in automated mode with a level 2 system. Out of today's perspective, there were cameras installed in the vehicle, so the vehicle was able to perceive the environment using cameras and to steer itself on the motorway. Then you might have heard about the DARPA challenges, the two grand challenges which took place in the desert, and the DARPA urban challenge, which took place in an airfield. I have some more slides on that, which were kind of milestones where actually the idea was born, especially later in the Silicon Valley area, to bring automated driving to the market. And then, of course, the next step was the Google self-driving car program, which was in the attention of the media around 10 years ago. So 2010, you heard a little bit more. It started right after the urban challenges, but about 2010, you had the first press releases from Google. They were talking about self-driving cars for the first time. In 2013, we had an event from a German manufacturer, from Daimler, the Bertha-Benz drive, which was also quite famous. And also in Europe, we had some challenges, the Grand Cooperative Driving Challenges, GCDC, which we had two, where the focus was more on connected automated driving. So these are some interesting milestones. There are a couple of more. Let's start with 2004, the first DARPA Grand Challenge. So the idea was to check how far vehicle automation was actually possible. And therefore, DARPA, the Defense Advanced Research Project Agency, initiated a race through the desert where there was a prize of $1 billion, and there were several teams who participated. Actually, were quite many, but no one actually finished. So after a few miles, even the most advanced teams were running into problems, having crashes, breakdowns, and so on. So nobody could finish this race. And therefore, just 1 year later, DARPA initiated the second Grand Challenge. And here, actually, a couple of teams arrived at the finish line, which was a milestone already. And as you can see here, the Stanford vehicle, Stanley, won this race. So you can see already the sensor setup here on the vehicle, quite impressive for 2005. 2007, DARPA initiated the third challenge, which was in urban areas. Here, the vehicles had to fulfill some tasks like parking, U-turns, and in this area were not just only robot vehicles, but also stuntmen driving around trying to challenge those vehicles. For example, at intersections, trying to provoke accidents. And here, this vehicle called BOSS won the challenge. It was the Carnegie Mellon University, which was later the basis for the self-driving car program of Uber, which might be known today by you. So there are a lot of teams are still there, maybe wearing now a different hat, but the people are still working on this. And as I said, in Germany, Daimler drove from Mannheim to Pforzheim in 2013 with an S-Class. The difference at Daimler was that they were not using so many sensors which were not production sensors. So they used, of course, a special equipped vehicle with many sensors inside the vehicle, but most of the sensors were very close to production. So there was no laser scanner on top of the vehicle, but the vehicle was using sensors which were already in the market or very close to market start. So this was also kind of impressive because there were around 100 kilometers in Germany, urban and rural roads, which the vehicle could perform on with a safety driver on board, but without the intervention of the safety driver. And that was 2013. Yeah, so there are several milestones, history. And when you look into mobility today, we see that mobility is changing. So we have these four important words, which you can spell case: connected, automated, shared, and electric. The overall automotive industry is working on this at the moment. And you can see there might be a transfer from individually owned vehicles, which we have today, to what we have at the mobile phone world already, mobility as a service. So today we have the connection as a service, so we are always connected. We have a kind of data volume in our phones, so we can surf the net, maybe a couple of gigabytes per month, which we can use. And maybe we can think about this for mobility in the future as well, so that we have some kind of volume which we can use to travel from A to B, buy this at the beginning of the month, or we have some contract, and then we don't own any vehicles anymore, but we use those connected automated vehicles. And how can these vehicles look like? I showed you in the videos a couple of passenger vehicles, and here are actually some which you might have seen before. But there are also different concepts, like the shuttles, as you can see here in the top right corner, the Google vehicle, which is not a normal passenger vehicle, but a very small, nice looking one. But of course, there are concepts also from other companies, from Volkswagen, from Audi, Cruise, and here a very futuristic one in the bottom right corner, which might be a vehicle of the future where you can sit in different positions, where you have some kind of turning seats, some different HMI concepts, and so on. So the world of automated driving not only follows one path, but is very diverse. You have very many possibilities. It doesn't have to be a passenger vehicle as we know it today. It can be really a complete different concept in the future, and you have different automation levels. But when we talk about automated driving, as I said at the beginning, we are not only talking about technical things. Automated driving is in everyday's media, and you can even discuss it like soccer at the bar in the evening, and everybody has an opinion about this. And we have tried to structure automated driving in different areas and different fields of actions, and we came up with this so-called 5-level model, where we have, of course, a technical level, which for me as an engineer is, of course, the most important level. But you have also an interaction level, you have an economic level, you have a legal level, and you have a social level. And in the following, I will go through some examples of these levels and analyze it a little bit deeper. So there are different research activities and different research questions on each of this level. For example, here, as you can see on the interaction level, it's the driver-vehicle interaction. You can see also here we have the vehicle, the driver, and the environment. There are also, of course, other forms of interactions between the environment and the automated vehicle, meaning between other traffic participants and the automated vehicle. It can be pedestrians and the automated vehicle. But here's an example for the driver-vehicle interaction in terms of transitions between different automation levels, maybe from manual mode to automated mode or vice versa. You have also the legal level where you have the law which you need to obey, also rules on the driver behavior, which we have today. And of course, we have to ask ourselves, does the automated vehicle need to obey the same rules? Because the automated vehicle might have different reaction times, maybe less than the driver. But does that mean that it can drive different style? Do we want to have it driven in a different style? So there's also the question questions. Do we accept automated vehicle? What do we anticipate when we think about automated vehicles in terms of safety? Do we accept accidents with automated vehicles? Will we have accidents with automated vehicles? How do we deal with that on society level? So these are quite interesting questions. And of course, we have many questions on the technical level. Driver monitoring for takeoff requests, HMI concepts of the future, but also everything related to function. So meaning the perception, trajectory planning, the function itself, and also all the safety validation. So these are a lot of stuff for research activities which are still necessary, but which are also ongoing, and there are some results already available. Let's go through all of these levels. So let's start with the technical level. So for me, this is a natural level where I feel very comfortable. So automated driving, of course, is a question of technology. We need to be able to perceive the environment, to model the environment. We need to be able to understand what we see. We need to understand what the future will bring. So we need to understand behavior of different traffic participants, and we need to plan our trajectory. We need to do this in an architecture which allows us to do such things in a safe way, because there are automation levels in which the driver is not the fallback route. So in case something goes wrong, the vehicle needs to deal with it itself, and it needs to achieve a safe state. And of course, we need to have on technical level new methodologies, which are in the process of being created in terms of safety, in terms of approval, but also in the development phase. We see a lot of artificial intelligence which can be used to achieve automated driving. How do we deal with artificial intelligence in terms of safety, in terms of traceability, and so on? So there are a lot of interesting questions for us engineers to deal with. Here you see the automation levels, which you probably know. Next to the automation levels on this slide, you also see the connectivity levels. So these are not standardized like the automation levels. We follow the SAE definitions here in this slide, but the connectivity levels, we have written in here 3 different ones: no connectivity, partial connectivity, which can also be called the state-of-the-art connectivity, which we have today, and maybe in the future a very robust, broad connectivity, where the vehicle is connected all the time to a very robust backbone, and we can communicate a lot of information in a very robust, safe, and secure way. Therefore, we can build this matrix, as you can see here, and this allows us to follow very interesting concepts of highly connected, highly automated vehicles. And as you can see, some examples here, some shuttles, some vehicles, some things which we have on the road already today. I think this is quite an interesting matrix. The components, what do we need for automated driving? I mentioned them already before. It's sensing, having sensors on the vehicle, which are usually are camera sensors, radar sensors, and LiDAR sensors, so optical sensors. We perceive the environment, we localize ourselves. We have very high definition maps on board, not the navigation maps, which you know from your navigation app or your navigation in your vehicle, but very high definition maps which have a lot of information on different layers, which we use to identify static objects like the road infrastructure, lane markings, maybe traffic signs, traffic lamps, and so on. Based on this environment which we perceive, so the static objects and also the dynamic objects which are moving, pedestrians, other vehicles, trucks, buses, and so on, we then have environmental modeling, and based on that we can generate behavior of other traffic participants. So we understand how vehicles move. They move following vehicle models. We know those vehicle models. We can calculate them. Pedestrians can move a little bit more complicated, but there are also models available how pedestrian moves. So we can also model pedestrians, and therefore we can generate the behavior. So we can look a little bit in the future how the scenery around us, the situation, the scenario around us develops, and then we can plan our trajectory. How do we want to move in a safe way and in a very comfortable way? And then in the end, we can use the actuators, which we more or less have already today in vehicles, to bring the vehicle into action and follow the planned trajectory. So there's the basics, how automated driving actually work. For that, you need a system architecture, which is maybe very different from the one that we have today. Here's one possibility, the so-called A model. You can see here on the lower left side, this is the sensors where we perceive the environment. Then we go up the left side of the A, we use the data, we filter it, we calculate it, apply sensor fusion, environmental modeling, situation analysis. And then we have the model around us of our environment, and we go down the right side of the A where we plan our behavior, our trajectory, control our vehicles with feed forward, feed backward control possibilities, and we use our actuators. You see here three different levels in this A model, the skill-based, the rule-based, and the knowledge-based levels. This is a model which is also applicable to humans. With humans, we have skill-based, rule-based, and knowledge-based possibilities. And here the idea is that the vehicle has skill-based function. You can compare this to ABS or ESP today. So these are functions which are available, get active in critical situations. Rule-based is something which we also have more or less today. When you think about ACC, adaptive cruise control, where we follow a vehicle in a certain distance at a certain speed. So there are certain rules to follow in a certain distance at a certain speed. Knowledge base is something that we not yet have completely. You see here on the left top side a database which is called experience, where we might in the future use experience of the overall fleet to improve driving, especially on automated in the automated case. So this is something that we are working on to bring knowledge-based experience into the vehicle. When we talk about the interaction level, so the next level, this is a lot of interaction between traffic participants, drivers, passengers, and as you can see in the future, the role of the driver might change, especially with higher automation levels. So the driver might be in the future called passenger if you have these kinds of shuttles where you're not driving anymore, where in fact you might not even have elements to drive this shuttle. So there might be no steering wheel, no accelerator and brake, maybe just an emergency button in these shuttles. So you have very different concepts to interact with these types of vehicles. But I believe also the HMI of passenger vehicles will change and will be adapted. And there are certain activities which we need to do some research on here as well. Here I have, to visualize this, I have a simple overview of a control loop. You see here on the left side the driver with the driving task, on the right side the vehicle. And usually when we are driving, we have enough visibility from our cognitive load to also perform. We are able to talk on the phone or talk to our persons in the vehicle, or we can listen to the radio, think about something else while we drive the vehicle. So we have the possibility to anticipate secondary tasks, and today we can do secondary tasks. So we can change the radio station, we can change the air conditioning and so on. We can talk on the phone, but basically we are in charge and we have to follow the driving task. When we talk about partial automation, so level 2, you can see on the right side in the vehicle, we have longitudinal and lateral assistance. So this might be a kind of traffic jam assist where you don't need to perform all the steering and accelerating and braking by yourself, but you are still clearly in the role of monitoring. So you can still do the secondary task, but in automation level 2, you are still in charge of everything. You are still monitoring the driving task, and if the vehicle makes some mistake or is in a situation where it becomes critical, you need to take over the steering wheel or step on the brake pedal. You are in charge. In level 3, conditional automation, this changes. So under certain conditions, you can do completely secondary tasks, which might be even texting, phoning, browsing, or whatever, looking out of the window. And the vehicle is performing the driving task. So the automated driving function is actually driving the vehicle. And since it's level 3, the vehicle can call you back. So it might require you as a driver to take over the driving tasks. And usually this is performed that the vehicle ideally informs you as a driver. You have enough time to perceive the environment. You have enough time to analyze what's going on, to find a critical situation, and to act upon that and take back the driving task. So this is ideally what happens. There's a nicely designed HMI with enough time, providing you enough information and enough time to perceive, analyze, and act upon this situation in which the vehicle calls you back into the driving loop. If you don't have enough time, or if the HMI is maybe not designed ideally, you might still take a decision, you might act, but if you didn't have enough time to think about it, it might be a panic reaction. So you know something is going on, maybe you even hear a warning beep or whatever, and then you grab the steering wheel, you do something. If you don't have enough time, then this might not be quite positive. On the next level, it's the economy level, so the economical level. At some point, of course, there's also invest to be taken, which is ongoing. So there's lots of research budget needed to progress here on the topic. You need to equip the vehicle with sensors, with ECUs, with the new architecture, which I showed you. So this there's a lot of money involved, and of course, you need to also think about the business model. So a fully equipped automated vehicle in level 4 automation might be quite expensive from today's perspective, since you have all these sensors and all this ECU on board. So you might think about different business models. As I showed before, mobility as a service might be a model, so that you actually don't own this vehicle. The vehicles are bought in fleets and they are rented out to persons, and they are constantly driving. Not like the vehicles today, which are mostly in the garage or mostly in the parking space, like my vehicle. I'm here at work. During the time I'm working, the vehicle is standing, and I'm only using it like twice per day, more or less. So there might be a different business model behind it, and a change of mobility. And here's an example of some of these sensors and components in the vehicle. The examples from Audi. And you can see how the costs of those vehicles increase by having all these components on board. The good news is there's a lot of potential in this technology. So here's an analysis from different consulting companies, and you can see here that the annual monetary potential is seen by different consulting agencies quite high for different automation levels. Quite positive. So there might be an economic case which makes this whole thing quite interesting. On the legal level, we need to talk about the laws first of all. Here to give you some example, there's especially in Germany or in Europe a law. It's the Vienna Convention. Not all the countries are part of the Vienna Convention, but many. And the Vienna Convention is valid since 1968. And actually, at the Vienna Convention, when you look at this quite closely, and I don't want to read it to you, but you can look later into the slides, it was actually forbidden to use vehicle automation according to the Vienna Convention, because every driver shall at all times be able to control his vehicle or guide his animals. So that was 1968. Luckily, in 2016, the Vienna Convention got adopted. So we see here on the last line that it's not only the drivers or to control the vehicle or the animal, but systems which have an influence on guiding the vehicles are compliant when they can be overridden or deactivated by the driver. So since 2016, the Vienna Convention is adapted so we can introduce level 3 automated driving. Of course, the Vienna Convention is not a German law, but the German law is based on the Vienna Convention. So in 2017, so 1 year later, more or less, there was also a change in the laws of Germany on the 21st of June, where vehicle automation is kind of legal in Germany. It's still complicated, and we don't have level 3 vehicle automation on the road yet. But the law was adapted, and certification of level 3 systems is theoretically possible. Still, nobody really knows how to do that in detail. It's quite complicated, so it's not yet performed. But the law is adapted, and we have boundary conditions which makes it possible to achieve level 3 vehicle automation. Next to the legal level, there's also the social level. And I already talked about acceptance, but there are also on social level ethics, which is a major topic. And one day prior to the change of the legislation was a report issued by the Ethics Committee on automated and connected driving. And this is a document which is available in German and in English, so you can download it. And it's quite interesting. 14 experts created more or less 20 ethical rules on automated driving. And it deals with this question: when you can't avoid critical situation, should you rather go left where you have one person, or you go right where you have a group of persons? How does the automated vehicle has to decide? But basically, in a nutshell, you can't. So the automated vehicle is not allowed to take ethical decisions where any kind of human life is involved. So these kind of decisions, one versus many, young versus old, and so on, all these ethical questions cannot be solved by the automated vehicle. So we are not allowed as engineers to program any kind of these decisions. But the social level also asks, of course, on acceptance. And as I said at the beginning, what kind of benefit do we have with automated driving? What happens in case of accidents? And the question, or the answer to this question, is so-called impact assessment. You need to perform for automated driving. There are different possibilities shown here, which are all not very good as a single possibility, but using a combination of these different possibilities, you can perform impact assessment, and that has been done in different projects. And I want to show you one result of one project, which was finished 2 years ago for the German bus. Here you can see a simulation of traffic with and without automated driving. So if I zoom in black, you can see here trucks, which in this simulation environment are non-automated. In red, you see manual-driven cars, and in green, you see automated vehicles. And we have performed such a simulation with all these boundary conditions, which you need to do to analyze different functions. And here on this slide, you see an overview of the results for the impact assessment. The very interesting color is the blue color, the darker blue color. These are the accidents that we can avoid with vehicle automation. In gray, we have the accidents which cannot be avoided by vehicle automation. And here on this chart, you see different systems, so different automation systems: traffic jam chauffeur, motorway chauffeur, commuter chauffeur, universal chauffeur, and urban robotaxi. And you see penetration rates. We have done the simulation for different penetration rates: 5%, 25%, 50%, and 100%. The good news, as you can see from this chart, is that there is an effect possible. There's even a nice effect. You can see here the accidents with personal injuries per year, which you can avoid, even with penetration rates like 25% or below. The bad news is that we do not achieve 100% to avoid all these accidents. You need to, of course, look into the boundary conditions. So what are the functional limits? We have looked here also only on passenger vehicles, not at trucks, not at other traffic participants. So you need to, when you look at such studies, you need to understand the boundary conditions. But I think this is a quite nice analysis. And if you are interested, we have the report available from BUS. Finally, my last two slides is an overview of the research activities. Here you see a chart on European level. These are all projects I know which are relevant. There are surely many more which have automated driving in different automation levels as one theme in the project. And you can see that we are actually doing research on automated vehicles since many years in many different projects on European level. There are many more national projects in the different nations, France, Netherlands, here in Germany, UK, and so on. But those, as you can see here, are on automated driving. And of course, you can see on the right side that in the recent past, many projects were initiated. Some of them are already finished. Some of them are quite ongoing, still ongoing. It is an important topic in research with many interesting facets. And finally, this is my last slide for today before I close this presentation and go to the question and answers. This is an overview from the Silicon Valley, where automated driving was also quite present. You can see many companies which are working on automated driving. This chart shows you only the companies with testing permits who are testing in the Bay Area at the moment. You can see it were last year permits issued, so quite impressive. And when you look at the companies, there are some tech companies, there are some known OEMs, there are some small startups, so quite a nice bunch of companies working on the topic in the Silicon Valley. You can draw the same chart here from Germany. There's a lot of things ongoing, a very interesting topic. So that was my brief introduction. Next week, we're going more into technical detail. We're going to talk about the functions in more detail, how these functions work. And in the third lesson, we're going to talk explicitly on the validation methodology, on safety assurance, all the data that's necessary, how to collect the data, how to store the data, how to apply the data, what is being done in real-world tests, what's being done in simulation.